Hi there, welcome back. So today I'm going to show you how to set up HEC-RAS model from HEC-RAS. So HEC-RAS 1D model, HEC-RAS 2D model. Subsequently, I'll show you how to set up those models. And even at the end, I'll show you how to set up steady and unsteady flow with salinity problem or water quality problem. And also I'll show you how to set up HEC-RAS model with sedimentation problem as well. So today I'll show you how to set up a model from HEC-RAS. It is steady 1D flow, and I'll show you the breeze problem. But today I'm not going to show you the breeze problem. At the end of this tutorial, means at the end of today's project, I'll show you how to calculate the score around the breeze pier. So, and then I'll end up with this piece of project. So before going to dive into our tutorial, let me show you how to install the software. Once we have the software package, then we can set up our model. So it's pretty easy to install the software. If you just go to Google and search for HEC-RAS, then it will show you the directory where we have the software package from HEC-RAS and US Army Corps of Engineers website, and you can just click on download. It will start downloading the file, and if you save it, it will save. So I already did it for you. I already downloaded the software and it's there. I'm going to show you once you have the software downloaded, because it is going to take a while, like 10 minutes or less than that, depending on your internet speed. So once you have the software downloaded, then you can just double click on it and then can click yes. So if you have enough space in your C driver, it will definitely start downloading the piece of software for you. So it's installing. And if you want to install the software in your Linux machine, you can do that. They also have this version. And once it's done with installation, then we can even install some example problems as well. You have to agree with their terms and conditions. Just click and then create desktop shortcut if you want, and then next, and then it will take a while to install the full packages. Okay, so by this time, what I'm going to do, I'm going to tell you that what I'm going to finish within this series of tutorials. So today I'll show you one steady state flow condition, but while creating this breeze model, I have to even create the boundary condition at the same time. What is the boundary condition at the downstream side of the river, and what will be the boundary condition at the upstream of the river? So usually what we do in hydrodynamic modeling or in hydraulic modeling, because this is hydraulic modeling, so our upstream boundary condition will be flow rate or discharge, and our downstream boundary condition will be water level. So how can we fix that boundary condition, right? So for designing any breeze, we have to even make sure that what is the class of the navigation. If you are make sure, okay, we have class 1 navigation route. So for class 1 navigation route, we have minimum vertical clearance, right? And we have also horizontal clearance. So based on that thing, we will place the pier and we'll decide our span of the breeze, and then what will be the height of the lower chord of the breeze from the 100 year of return period of a flood. So we'll analyze historical data, flow rate or discharge data, and also water level data to calculate the 100 year of return period. So I'll show you that, but today I'll show you only how to set up the geometry of the model from survey data. I have the real survey data. We assigned one company to survey the river, and we have the data. I'll insert this data is in Excel file. So I'll show you how to create that geometry file from that surveyed data. That is the main objective, but in future tutorial, I may not show you this same thing, right? We don't need that one. Once you know how to insert geometry, and you can do that thing, that is not a problem. So my installation is finished. So let me try to open that software package from here, HEC-RAS. So it is there. If I double click or single click, it doesn't matter, it will open and is asking, okay, are you agree, right? Agreeing or not? So yeah, definitely we have to do that. And do you want to even install the example project? If yes, we can do this, or no, then we don't need that. Okay, so that is the main window we have. So before going to start setting up the model, let me just describe the study area first. So you can see, right, in the map that we can see one river. So this river is basically a meandering river that has spiral shape. If you see from the top or bird's eye view, it's the plan view. So that's the upstream. Let me just annotate. So water is flowing from upstream to downstream. That is called upstream side of the river, and here it is called downstream side of the river, right? And then we have surveyed the river, right? And here you can see that's the bridge. Here they're proposing, okay, we have to build a bridge here. That's the connecting road. That there should be the bridge. So if we wanna build a bridge there, so what will be the impact on the river? We have to check if the river is morphologically stable or not, right? And what will be, because if we build a bridge, then the river total conveyance area will be reduced, right? Because of this bridge pier, we'll have bridge pier there, and there the river width will be reduced. So then there will be some scouring because of that bridge. So we have to be able to calculate that scour, and then we have to take measure of the banks of the river. If the banks of the river are not stable, morphologically stable, if it changes with time, then definitely we have to do some bank protection work there. We'll suggest that one based on our calculation and the survey. We'll do that. But today I'm going to show you here, that is the real world case. So we surveyed this river from a survey company, and they did the survey like this way at 500 interval. They took different reading, cross-sectional reading, using their echo sounding machine and survey instrument. So that's the plan for survey. I'm going to show you that plan. So here it is. Before surveying, they made the plan like this way. And okay, let me just quickly clear that, then you'll see clearly. So that's the plan. So that's the upstream, what is coming from upstream to downstream side. So at the same time, what you have to remember, that is the left bank, you have to keep in mind, and that is the right bank. For HEC-RAS model, it matters if water flows from upstream to downstream, and if you are standing there and if you're looking at the flow, and on the left side, right, the left side it will be left bank, and on the right side it will be right bank. But what we need in this plan, we have to survey such a way that we can measure the cross section from left bank to right bank, from left bank to right bank, because this HEC-RAS model can take, right, it can take the cross sectional value from left bank to right bank, right? So that's what we did here. So the survey company, they just made this plan beforehand, right? That okay, they'll take the cross section here, and at 500, this interval is 500 meter, right? 500 meter, half a kilometer. So they just made this plan, and then they started their measurement from here. So if you, this is the bridge center, and then that is the center line, okay? And here upstream cross section 1, 2, 3, 4. So if you go upstream, your number of cross section is increasing, and CU means cross section upstream. And if you go downstream, then we have D, right? CDS means cross section downstream 1, 2, 3. So number is increasing, you are going to downstream direction. But in the model, you can import this cross section, or you can create the cross section from upstream to downstream. We'll do that. We'll start the cross section from upstream to downstream, and the upstream cross section number will be the higher number, and the downstream cross section number will be lower. So that will automatically be fixed. If you provide two number, 1 and 2, then 1 will be the downstream and 2 will be upstream. So that is the notation. The model, the modeling software HEC-RAS, it will automatically understand that the minimum value is the downstream cross section, and the maximum value is the most upstream cross section. And the cross section you are inserting, whether you are inserting right and wrong, it doesn't matter, but the model will assume that okay, you are inserting from left bank to right bank, okay? The maximum value will be most upstream, and the minimum value will be most downstream, and the cross section we are inserting, that will be from the left bank to the right bank. So that's why now we have idea about which one is left bank and which one is right bank, which one is upstream, which one is downstream. So at the upstream cross section here, we need boundary condition, right? So we'll provide Q, flow rate or discharge as boundary condition, and at the very downstream, if it is there, we'll provide water level, right? So for Q, we'll calculate 100-year return period of the Q. So we have historical data from different observation stations, and then we'll use Gumbel distribution method, Gumbel extreme distribution method to calculate this 100-year return period of flow rate, and same for water level. Then if we use, that means we are designing the breeze for 100-year of return period. If there is a flood that has a return period of 100 year, then the breeze has to be survived, right? The breeze will survive for this type of flood or rainfall event or flooding event, whatever it is. So that is the condition. So we have to be able to calculate this one. So these are the input data. Today I won't show you that how to calculate Q and W, but in the next tutorial I'll show you how to calculate 100-year return period of flow rate and water level as well. These are called statistical analysis. I'll show you that using Gumbel extreme value distribution method. So today I'm going to show you how to even create the geometry from HEC-RAS. If you have any survey data as Excel file, we have to be able to create the geometry. And then I have this data ready, so I'll insert this data, and the model I'll run today, it will be steady state, so there won't be any time series. The one value of Q will be fixed for the entire time, and one value of water level will be fixed. Okay, so that's that. Okay, I'm just clearing this drawing I have, and I'm going back to my model setup. So I have this software package open, right? Let me just introduce you what we have here. So here it is the open. If you have already developed your model and you can open it, you can click there and it will open, and this button, it will save the model. And here you can even open the editor of geometry. This way, if you click there, it will open, and then we can insert our cross section. I'll show you shortly this one. And you can do the same thing from editor. You can go to geometry. So same thing you have as a menu bar, and same thing you have here in the as icon. Okay, and next thing, it is the, if you click on that, it will show you what it is going to do, right? This is geometry, that is that, that is that, and you can, this is the 3D. If you want to see any cross section, this is the RAS mapper, it is showing here, right? RAS mapper, and it is editor, steady flow editor, and you can go there, you'll find that same menu. The same thing, I'll show you which one is doing which thing. And if you want to see the profile, you can click there. If you just put your cursor there, it will show you the name of the menu or the plot, right? And at the same time, if you want to run steady state, steady means the flow rate, water level, velocity, if it is constant with time, then it is called steady state flow condition. So that's why they are showing that someone is running on a flat surface. There won't be any change. But here, that's why it is called steady state. It is running. If you want to run the model, if you click that button, it will start running that one. And if you want to run the model as unsteady, that means if flow condition, water level or velocity will change with time, then it is called unsteady flow condition. So that's why you can see someone is running on a surface or on a wave that is changing, right? So same thing for here, it is the unsteady, quasi unsteady sedimentation. You can see some dust, and here it is also dust, but the people or the person is running on a flat surface. That means it is water quality, and you can see the color, right? Water quality model. And that's that. If you want to see the result as a tabular format, you can click on that. It will give you the summary of the data. I'll show you after running this model, and there are other options to display and extract the plots and other information. I'll show you that. So since I'm gonna set up this model from HEC-RAS, so just follow this step. What I'm going to do, at first click on file and then new project, and when you are done, you have to specify where you want to save your project. So here I'm not going to save in my C drive because it will kill my space. I'm going to select another drive, D drive, and I'm going to direct it to there. Okay, inside that HEC-RAS I'm selecting this directory and give the title as what? So this will be by the name of a breeze. Okay, breeze model, because ultimately we are gonna finish this breeze model, breeze scour. Okay, breeze scour model, this is the name of our project. If you click OK, it will create this name, and you can see, and what will be the unit system for the time being. Okay, click OK, not a problem. So here it is, we have the project name, and if you want to change the unit, because we'll use our SI unit, so here you can see by default it's customary, because this software they developed from American US Army, so that's why in US or in America they use US customary unit, means feet and pound system, but we are not gonna use that, right? We have the survey data in meter, velocity in meter per second, and we have the flow rate or discharge as meter cube per second. So that's why I'm going to change it. If you click options and then unit system, then you have the option to change it. So we are going to change it to system international. Okay, then we have the unit. See, you can see we have SI unit. Now what you have to do, you have to click there, view or edit geometric data, or you can click there, edit and geometric data. It is the same. Okay, it's gonna open this window, and what you have to do, let's look at the map. So we have this. Okay, so this is the upstream and that is the downstream. So what is coming from upstream to downstream? So at first what you have to do, without thinking, can you see that? Yeah, river reach. Okay, you have to draw the river reach. What is a river reach? A segment of a river is called a river reach. Okay, so if I click there, so it is activated. I can draw the reach, and what I'm gonna do, I can even draw this way a line, straight line, it doesn't matter. Okay, and double click, we have one reach, and you can write the name. I'm gonna give the name as river. If you know the name of the river, you can write the name, and if you know the segment of the river, right, you may have a big river, right, very long, and then you will have some tributary, distributary, so that these are the reach of a river. So then you can write the name. Okay, I have the big name, and this is the tributary of the river, that means it is the reach, but for this case I'm giving the river reach, okay, as reach name. So I have one river, one reach. See, it is showing because I have drawn this line from upstream to downstream, so it is showing that this is our flow direction. Okay, now I have to insert that cross section, right? The river means cross section. So here, see, if you click there, it will open the cross sectional editor. We can add cross section. So if I click on there, we don't have any cross section, and we have to create one, and we have the option here. See, the station, this will be the measuring station from left bank. So from the left bank, you have to give your changes or the distance. It will be 0 on the left side, and what will be the elevation, you have to put that, and then you have to go to the river, and then you have to measure the elevation. So let me show you how it looks like, the real survey data. So here is the survey data. You can see I already mentioned that we have total 20. Here you can see that we have total 20 cross section, and UCS means these are the upstream cross section, and in the plan you can see the maximum number for this case, because this is the plan. They just mentioned, okay, they will take 12, but in reality they took 17. So the 17 means it is the most upstream, and 1 means it is the upstream of the breeze, right? So our most upstream will be the maximum number of CU cross section. So that's that. See, it is 17 means most upstream, and if you go to 1, it is close to the breeze. And then we have CSDS, right? We have CSDCS. This 1 means it is close to breeze, and 3 means it is away from the breeze to the downstream. So this 3 means it is the most downstream, and the 17 means it is the most upstream. So our total number of cross section is 20. So if I just specify, because in HEC-RAS, the way it just stores data in DSS system, data storage system, that the maximum number of the cross section, they will put it at the upstream, and the minimum number of cross section they will assume, okay, it is the most downstream. So if we create one cross section of at first 2, let me just show you that. At first you have to go to options and then add cross section, right? And before going to do that, let me show you, if I open one file, the most upstream one, 17, we have the plot. So what do you have to do exactly, right? We know we have to do, we have the point they started the measurement. This is wrong, this should be right bank because I corrected it. This is the left bank. So what they did, they just started, this is the 0, okay, they started the measurement point 0 and here, and they measured the elevation, it is 5.11, and then they just they moved to the river 6.27, and next point the elevation is 3.9, and then they just cross the river, and on the other side that is the right bank, and they are done with that. So they also mentioned, okay, this is the left bank LB and that's the right bank RB, right? This is the cross section, this is across the river, that's why these are called cross sections. So what do you have to do? We have to copy these two column and we have to paste it there. So how can we copy that and paste it? These are the manual job we have to do 20 times. At first we have to create the cross section as a blank cross section. So first go to options and then add a cross section, and it will ask you the number. You have to put the number, any number you can put, but since you know we have only 20 cross sections, right? In total we have 20. So if I put 20, it will be the most upstream, and if I provide 1, it will be the most downstream one. So I'm gonna enter as 20, right? And it is not showing anywhere because it doesn't have any idea where to show, right? And then I doesn't have any idea that what will be my next cross section, because I know that I have 20 cross section, so the minimum will be 1. So I'm giving the 1. And okay, before going to do that, I can even copy this two cross sections, two columns of this Excel file, and that is the trick we have to apply. You can insert one by one, or if you click there, here it is selecting, and then if you paste it, it is just pasting the entire data set. You just copy it, column, the station and the elevation. Okay, then what you have to do, you have to provide these values. So if it is most upstream, then what is the next, right? What is the distance from the left of the bank, from the channel of the bank, and from the right of the bank, the next cross section? What is the distance? You have to provide the distance. So for this case, we know if it is most upstream, the next cross section is located at 500 meter. Since we are using SI unit, so I'm giving 500 and 500 everywhere. So what will be the Manning's coefficient? We are giving the standard value 0.023. We can give that, and in channel it is different, on the bank it is more than that. So in channel I'm giving 0.020, and I'll use the same values for all of these sections because we are selecting a cross section that is mostly 3-4 kilometer, or more than like 10 kilometer, less than that. Okay, so that's it, we're done with this one. So if I click apply, you can see, and at the same time you have to specify the left bank. Which one is the left bank? The starting point is the left bank. Okay, I'm copying that and I'm pasting it here. And what is the chainage of the right bank? It is the, that's why in the survey data they mentioned that which one is left bank and right bank. So it is, for this case it is this one, and I'm pasting it there. If I click apply, it will show you that cross section. See, it is the cross section it is showing. So the good thing about this software package is that you can copy, because each time if you create one new cross section, you have to do the same thing. Because if you know that, okay, your distance from this cross section to that cross section is 500 meter, and your, if you keep this Manning's coefficient for same for all of these cross sections, right? But this will be only changing, and the contraction or expansion, because on the left side and the right side we can keep this as it is, 0.1 and 0.3. These are the coefficient for steady flow, and we have this cross section. We can copy this entire cross section, so it will copy everything, and next time we will only replace these values. We'll keep this as it is. Okay, then our task will be easy. So what I'm gonna do, I'm gonna even create another cross section, but this time I'll create new one. That will be the downstream one. Okay, so create new cross section, and I'm giving the name as 1, and it is new one. And since it is the most downstream, there won't be anything, right? That's why this downstream reach length, it is 0 from the downstream cross section. Then it will understand, okay, this is the downstream one. Okay, and then when I'll enter the value for this one, I'll fix everything. So now I have the cross sections, right? If I close it, see, now it's gonna show you what is that. Since we didn't enter the value, that's why it's not showing this line. Okay, but we have, right, we have entered the value for 20 and it's showing the length, the cross section. So we can enter, click again, cross section, and then we can create the dummy cross sections. We can enter, not a problem. We can enter the value. So the 3 downstream cross section of 3, that is the most downstream. Let me copy that and it will show you this one. So which one will copy? This one. The first value is the left bank and the last one is the right bank. Okay, so keeping in that mind, so here it is, click there and paste, and this will be 0, and that is that right bank. So if we click apply, so now we have the most downstream cross section, right? So that's that. If I click or close it, then we can see which one is that one. Okay, even after inserting all these values, we have to specify, okay, this is my cross section. Okay, and then if I open it again, see, you can see, since we are selecting this one, it is showing us, okay, that is my left bank, that is my right bank, and it is gonna show you everything. And you can even scroll from one to this one to that one, this one to that one. See, that is the, if you click this one, it is gonna change to this one to that one, and the red dot means it is specifying where you have the bank line. And this point, you can select your bank line is this one or that one. The surveyor said, okay, this is the bank line because they started with the bank line, right? So that's that. So now what I have to do, I have to insert the intermediate stations, right? So I'm copying this 20, I'm copying this, and then I'll replace this one by one. Let me just copy, option, copy current cross section, and I'm gonna give the name as 19 because the next cross section will be 19, and it is gonna reduce the number from 20 to 1. Then it will show, okay, I have the cross sections from upstream to downstream. See, we have the 19. Now it is same because I'm copying, and then if I copy the current cross section 19 to 18, then I can give 18, right? And I'll replace these values later on, keeping this same. And then it will be 17. These are the manual job. That's why I'm starting from scratch so that you can understand what we need to do. Now, what do we need? We have 17, right? We have 17. Now we need to have 16. Let me check if I miss anything. No, we have the list. If you click there, 20, 19, 18, 17, 16. So next we'll have 15. And after that, we'll even insert other values as well. And then it will be 14, and the next one will be 13, and then, yeah, you can repeat everything. You have a 12, and then once it is done, then the model run is pretty fast. Then it is 11, and then it should be 10. We have 10 more to go, and this should be 9, and next it should be 8. Let me make it fast. And then we have 7, then we have 6, then we have 5, then we have 4, then we have 3, and we are almost done. Then we have 2, and we already have 1, right? So these are the cross sections. If I close it, you can see all these cross sections from 20 to 1, but we didn't even provide it, right? We didn't provide the exact value of cross section from 19 to 2. We are already provided only for 20 and 1. So let me just open it again and select the 2, or no, I'm starting from the beginning, 19, and I'm gonna close the previous 20 and the first upstream one, and then I'm selecting one by one. So the 16, this time it will be the 19. Okay, so that's that. I'm gonna copy, and then we have to paste it. How can we paste it? Because we have to replace this one. Click there and paste it. The first value is that one, and copy this one, and each time you have to replace this one as well, and apply. It is gonna change, right? We are done with this one, and this will be 18, and I'm gonna select that one. These are the laborious tasks we have to do. No way, that is the model setup. It may take few days, it doesn't matter, we have to move. Okay, I'm done with this one. I'm copying this one, I'm pasting this one, and apply. Each time you change anything, you have to apply and then go next. So we are gonna do for 17 right now, and then I'll make some interpolation. So these are the cross sections. It is pretty easy because within 500 meter, if we interpolate right at 100 meter interval, that is pretty quick. That's why you don't need to have, right, you don't need to even spend a lot of money to measure the cross section at 50 meter interval. We don't need that. We can interpolate. This is the option we have, so we can utilize that one as well. And then our model, because we are just focusing on our breeze model, so we don't need to even worry about the cross section that are far away from upstream, only to the survey data. Even we can use DEM data to create any model, but since it is a real case for a bridge design, that's why we spend money to survey this river to make our model perfect as much as possible. And you can utilize this one as well. This is your opportunity, I think. You can see and you can replicate. So these are the real world case. Otherwise, if you see some problem that are really fancy, people are making it without showing anything, yeah, we can set up the model within 10 minutes. That is possible, but it won't help you anymore. Okay, so that is the issue we need to do. So I'm gonna replace this one as well, and I'm gonna copy this one and paste it here. Each time you have to keep in mind, I'm talking and I'm just doing this thing. Maybe I can make a mistake. It is also possible, but since I did this thing many times, so I can even do all together, not a problem. So each time I can copy, I'm just making track of everything. Okay, I'm copying. That's why I'm following some sequential order, right? Each time, see, I didn't change it, so I have to change it, and then I have to click on that and then paste. When I'm done with pasting, I'm copying this one and then I'm pasting it here, and I'm just applying, and then I'm just moving to the next point, and then I'm just opening the next one, 10, right? And then see, I'm copying it. Okay, I'm selecting this 2, and then I'm copying it, Control C, and then I'm going to that one and selecting here and pasting it. Again, I'm copying this one and I'm pasting it here and applying, and then I'm going next, and then I'm just closing this one, because if I keep open, then I won't be able to even track which one I'm copying and pasting. And then here I'm in number 9, and I'm copying it again because it depends on the river cross section. You can see at the same time how it looks like, right? The same cross section we have here, and we can see we have the same cross section there. I'm copying and pasting at the same time, and again I'm just replacing the right bank because left bank is always at 0. Okay, so which one is next? This one, number 9. So this is how we can import. There is no other way to import. If you are done with your geometry, then you can manipulate. There are a lot of options to manipulate geometry. That's why this is the most laborious thing we are doing here, right? We are done, almost done. We are done with 10. Now it's 7. 7 means it's the upstream cross section number, not the 7, because we have 2 downstream cross section as well. So we have to even enter those cross sections. So see, that's why the river is meandering and it is changing its length of the cross section, right? See, it is just changing. And if you see, it is half of this. No, you can see here, if I just move this red bar, right, zoom in, you can see the bottom of this. So it is automatically showing that one. So don't think that, okay, we have half of this cross section and we have missing data. It is not like that. So what is next? It is this one. So we are almost done with our upstream cross section. So now what we are doing here, we are just coming from most upstream to the bridge location, right? and then we'll cross the bridge and we'll go to downstream side, and then we'll be done with inserting our cross section. That's why when the river width is less, right, from half a kilometer to 263 meter, then we're just building a bridge so that the length of the bridge is not that long, only to reduce the cost, right? So that's why survey is necessary, or these are called reconnaissance survey. You have to inspect where to build this bridge, and if you can do that, definitely your cost will be reduced. Otherwise, without inspection, without reconnaissance survey, how can you build a bridge? These are the steps you have to follow, and then you will be able to build the bridge, right, with less amount of money. This is called economy. You have to be able to design the bridge using your engineering knowledge and at the same time with minimum cost. So that's why we need engineers, otherwise we don't need them, only to calculate efficiently, economically, and cost effectively. They have to select the building material as it is cost effective, and with minimum cost the bridge should survive, right, at least for 100 years, because we are going to select the return period of a flood for 100 years, and we are designing this bridge for 100 years, so it should sustain up to 100 years. It has to, otherwise there is no engineering. So we have to be able to calculate this. That's why I'll show you how to calculate the bridge pier, because if the bridge is there and if there is some kind of flood that is not even 100 years of return period, but still the bridge is facing problem, so it has to survive with different types of scouring. And this is how we calculate the bridge scouring. I'll show you in this, not today. Today I'll show you how to only run the model, how to display the result, because it is taking too much time to even insert. When I'll be done with this laborious task, then I can show you how to calculate the input value. If you are correctly, okay, if you have your survey data, you have everything, but how can you calculate the 100-year return period? You have to follow some rules, right? You have to follow some guideline. So there are some guidelines. We have to follow this, and once you are done with that one, you can use that value. And why we are just running this model for steady state flow condition? Because we don't need to run the model for unsteady, and the location of the bridge is another point. If there is no tidal condition, if there is not that effect of unsteady flow, means if the flow condition is constant, that is more effective, right? And if you can change it to unsteady, not a problem. But most of the cases, if the run condition is simple, we can do that. Okay, now we can finish the rest of the cross section. So here is that one, so we can copy number. Yeah, I can just close that so that I can even make track of this quickly. Let me close this one, this one, this one, this one, this one, and we have many. See, so yeah, what do you have to do? You have to copy the number 3, right? So if I copy number 3, let's see what we have. So we are done with that one. So keep in mind that number 3 is the number 1. Number 3 is the lowest one, okay? So it will be 1 because it is starting from the bridge section. So if I copy this one, and then if I paste it there, it will be, you have to click there as usual, and then I'm just copying this one. That will be our right bank, and apply. So we are done with that one. We have 2, and then downstream section number 2. Yeah, that one. These are from left bank. You have to keep in mind. And I'm just okay, it should be the next one, and pasting it there, copying and replacing this one, and then apply. So we have the last one. Okay, I think we already, right, we already maybe replaced that one. Okay, let me just check it before proceeding. not this one, it is not the one I'm getting, it should be number 3. Okay, so that's that. Just make sure that we are on track, and I'm just copying and pasting. Maybe it's the same one I pasted. Yeah, it's okay. So I applied, so we have our cross section. So what I have to do, we have to save it. How can we do that? Go to file and then save geometry as. Okay, we'll save the geometry as our original geometry, because we'll interpolate, right? We'll interpolate that geometry, that will be our interpolated. So we already saved it, and now if I closed it, right, if I close it, then you'll see we have the geometry here, original one. I'm opening it again here. What I'm gonna do right now, I'm gonna interpolate that geometry with, right now we have 500 meter distance in between two sections. In between section 20 and 19 we have 500 meters. So I'm gonna interpolate that geometry, and I'm gonna make 100 meter interval. You can even use more than that. So how can you do that? If you click there, tools, and access interpolation, cross-sectional interpolation, means within a reach. Since we have one reach, we can even interpolate within a reach, then it will interpolate every section. Or you can even interpolate in between two sections if we specify. We can do that. So since we are interpolating everything, we are selecting within a reach. And if you select that one, see, it is selecting every reach. If you have more than that, you can select from this drop down menu. And what will be the maximum distance between these two sections, right? It will be 100 meter. And what will be the interpolation method that you are going to select? It will be linear interpolation. And then you can select here interpolate, then it will be interpolating. And if you delete it, you can delete that. If you think okay it's wrong, then you can delete the interpolation, and it will only delete that interpolated cross sections. If you close it, you can see the interpolated sections. Okay, and if you want to delete it, if you think okay I made a mistake here and then I'm gonna delete it, then you can do that. Go to interpolation and then section and delete it. Okay, then it will be deleted. It will only delete those sections. I'm gonna do it again to show you the processes we have. It is only 100 meter interpolate and that. And now I'm gonna save it again, save as interpolated section. Okay, instead of original one, because I just preserve the original one so that I can even change whatever I need. Okay, but for any bridge analysis we don't need to do that. Okay, I'm gonna do it. So now we have our interpolated section. We are gonna use that one. What do we need to do right now? We have to even import our boundary condition. So what will be our boundary condition, right? So we have to provide here this section number 20. There we have to provide the flow rate, the discharge, and at the downstream level at 1 we have to provide the water level. Then the model will understand, okay, this is the discharge here, the very upstream, and that is the water level. So it will it will keep that in mind, and then it will calculate, it will solve the equation, the differential equation, and then it will give us the water level for water level, velocity, and flow rate, everything for right at each of these cross sections. So now we have to even provide that boundary condition. So for running any model, we need the cross section or the bathymetry, and then the boundary condition, and then the run condition as well. So for this model we have that. If you click on that edit, and we have the option steady flow condition, so we are going to select the steady flow condition. So if it is steady flow condition, we will have to provide the flow rate here, right? We can do that. And what will be the flow rate for this one? I'll show you how to calculate that 100-year return period. So for this one I'm giving that 55 cms, means meter cube per cubic meter per second. So you can see that here. And if you want to change the name, you can add more profile. You can add as many as you want, up to 32,000 profile you can add at the same time. But we don't need that. In future videos we'll add only 3-4 profiles, and we can compare different conditions. If you have 100 year return period of flood, if you want to analyze 50 year, 500 year, then you can add all this profile all together, and you can run it, and you can check which profile is giving you right what will be the water level, maximum water level, and other velocities. Then based on that, if you don't need to even select that 500 year of return period, then you can decide. There will be based on the difference, right, or the height of the water level, then you can decide which one you are going to select. Because if you want to select 1000 year and it won't affect that much, then you don't need to select that one, because it will increase the construction cost of the bridge. So I'm going to select only one profile for this time. And then if you want to change the name here, what do you have to do? You have to even select there, okay, rich boundary condition. You can do that. If I click on there, and we have to even provide the boundary condition, downstream boundary condition, okay. And we can, what we can do, we can even select this one. We can even add, see, add a flow, change location. If you have two river connecting together, we have or even you have different flow rate that is contributing. You have any tributary, distributary, even you can add at which section. If you have any tributary of a river at section number 15, you can select that cross section and you can add that one. In the future video, maybe I'll show that, not a problem. But today I'm gonna just show you only one single reach and single simulation. Then I'll add different condition as well, okay. Since I'm just inserting everything from the beginning, so it is taking a lot of time, and the length of the video may be even longer than 1 hour. I don't know what is gonna happen today, so we can even do that, okay. So that's that. And if you want, you can even add multiple location. These are the options, and here from here you can even change the edit the profile names. If I click there, even you can change the profile name. I can give you, it is like 100 here, okay, 100 here flow, so that you can track this is for 100 here, and you can add more profile for 500 here, okay. You can add that. And if I want to select that rich boundary condition, okay, rich boundary condition, then what will happen? We need to provide the downstream boundary condition. See, by default it is showing the downstream boundary condition here, right here. So when I am selecting that downstream boundary condition, you can give known water level, because we have the known water level for 100-year return period. And you can even provide the critical depth. You can provide the normal depth as a slope 0.0025, and you have to calculate that one, or you can give the rating curve, right? And you can even delete everything whatever you have. So I'm gonna give known water level. So I have the water level known. If I double click there, and I can provide that, this is 7.85 meter, okay. So I'll show you how to calculate that one from historical data and from Gumbel distribution method. I calculated this value, and it needs a lot of calculation. I'll show you that how to do that in the next video, so that you can even calculate that one as well. If I click OK, so we have our boundary condition. I'm clicking OK. So we have our flow rate at the very upstream, and we have the boundary condition water level at the very downstream, right? So what do you have to do? We have to even save this, okay. How can you do that? Go to file and then save the flow data. So then you have to provide what is the flow condition. You can give the flow condition as 100, okay, year flood, 100-year flood condition. That's that. And if I save that, so now we have this, see here, steady flow 100-year flood. And then what do you have to do? We have to even provide the run condition. Go to run and select steady flow condition. If it is unsteady, we can select unsteady. In the future video, we'll do that. So I'm going to select steady flow analysis, and here we have to select which geometry you are going to run, okay. So I'm going to select, so we have two. I'm going to select the interpolated, and then which steady flow condition you are going to select, or unsteady flow condition. So we have only one profile. I'm going to select 100-year flood, and which will be the flow regime. We know that for river flow it will be subcritical, right? If the flow number is less than 1, the flow is subcritical. So most of the river flow, these are subcritical flows, so we have to select this one. So I'm going to select this one, and we don't need to even select that floodplain mapping, because we are not running a 2D model. When we will run that, we can do that as well. And then you can provide one short ID as 01, because if you want to change the condition or plan, it will change it. And then what you have to do here, go to file and save plan. Then it will ask what will be the plan name. So I'm going to give the run 1, okay, run condition 01, or run, it's okay. And it will, because we already provided the ID, it's okay. So you have to give this ID, it's already there, and this will be run number 1. And if you compute, if everything is okay, then it will start running the model, okay. Otherwise it will display the problem we have, right? And it will locate the problem where we have the problem at. It will even display the cross-section number. We can even go to that number and we can select it if there is any difficulties or any problem in that calculation. And okay, let me just run it quickly. It will be pretty fast. I'm hoping it's going pretty well. See, there is no error. So run completed. The process is successful. We can see the result right now. So that is, I'm just closing that. See, if I open the geometry this time here, and if I even select the flow condition cross section, we'll see the water level, right? See, now the cross section is filled with water. This is the most downstream one, and if you click there, you can go to upstream, and if you can go to the next cross section, because we interpolated it is just 19.8, and then it is just giving the IDs, and you can see water is just, we have this water, and you can see the velocity profile. If you want to see the velocity profile, you have to go to options, and then you have to select that variables, right? And then we can see, I'll show you that how to do that. I'm just showing how to even see the result. If you want to see the result as summary, you can click there, the table. It will show you the table values for each of these. See the profile, we have one profile. It is giving you the flow rate. Since it is steady flow, the flow rate is same for all, and you'll see the minimum, right, the elevation, and this the water surface elevation, right? And if you have any critical energy, it will show that, and this is the energy grid line, okay? And then it is going to show you that slope of this line. These are the slope at that cross section from this one to that one, and the velocity, channel velocity, and the flow area is, these are called conveyance area, and the top width of the channel, right? And it is going to show the Froude number, means it is less than 1, definitely the flow is subcritical. So this is how we can even see the result of this model, okay? You can close it, and then if you want to see the long profile, you can click there. You can see the long profile of this channel, right? You can see that. And if you want to see other, because I'm not going to show you the result analysis right now, I'm just going to show you how to view results, right? And if you can open your cross section from here, right? Cross sectional velocity, we can even see, and here even you can gonna see the variables, which variable you want to see. At present time, it is showing the water surface profile and everything, right? It is showing this way. So in the next run, I'm gonna change it because I want to see the velocity distribution here. That's why what I have to do, I have to change the run condition a little bit. Then you'll be you'll feel that okay, that is the thing you want to know. So I'm gonna select the steady flow condition. No, here from run steady flow analysis, right? Steady flow analysis, and then from option go to flow distribution locations, right? And then you have to select this as many number as you can. I'm gonna select 10, okay? The left bank, right bank, 10. It will just divide this left bank and right bank as 10 segment flow distribution location. And then I can even select this thing as 10 as well. It doesn't matter because we already specified the global variable as 10 segment. So if you just click OK, then you have to even save the plan as, okay, save plan, I'm saving it. And if you run the model again, then what will happen, you'll see that, okay, it's gonna run. So that's why HMS and HEC-RAS, these models are pretty useful for any engineering analysis. That's why people are using that this type of softwares, this ACC or HEC softwares, because the runtime is pretty low. See, it's running within a few seconds, right? And see, we are done with the run. And what I changed, you can see we have the same profile, but this time, see, if I change the variable and velocity distribution, and then if I click this one, plot velocity distribution, if I click OK, then you will see we have the velocity distribution, right? We have the higher velocity because it is a kind of bend. That's why you can see we have this outer, this is the inner bend, that is the outer bend, and we have the deep portion there, right? So we know that for meandering river, the deeper canal or the thalweg, the deepest point located at the outer bend. So here it is, and you can see the velocity is 2.2 meter per second, and this is how we can even calculate the velocity. And how can you even import or export different maps? So from here, if I just go to file and if I copy the plot as clipboard, and if you open any Word file, right, you can even paste it, your report or your publication, whatever you need, right? You can do that. I'm gonna open a new one and see if I just paste it, it's looking like pretty good, right? And this is how you can add the plot, and you can even change your cross section by here. This is 13, and anywhere you can go and you can see, you can check, right? You can check and you can copy. You can go to file and copy to clipboard, and you can quickly paste it there, and you can see it is showing the date, and it is showing you the variables, velocities, and everything, and elevation and station as well. So this is how we can export, and you can run the model from the very beginning, right? From a generation of geometry, from survey data to run the model. In the next tutorial, what I'll show you, and you can even see if you go to view, and if you want to see the XYZ perspective plot, and you can see the three-dimensional plot in a two-dimensional system, right? You can even change the view. If it is not okay, you can even rotate it, see? And now you can see from the upstream to the downstream, right? And you can tilt it this way, okay? So that's that. We can do this way, you can see, and then that's the river flow is coming from upstream to downstream, and you can see the cross sections are changing, right? And you can even create animation, you can even run it, you can even, right? You can go from one section to another section. See, this is how we can go. So that's that. This is another view you can see all together. So I'll show you this thing in details in future videos, right? Even from this one, when we'll have more profile, more plan, then we'll even compare all together, not a problem, right? So that's that. And even for 2D model, we'll use this RAS mapper to even display our velocity profile and everything. I'll show you that one as well, right? We have GIS tool, and we can use that one. And then from help menu, you can even use different, it's user manual if you want. So you have everything there, right? You can do that. So these are the options you have to even explore by yourself, but I'm going to show you only the basic thing, that how you can start developing or setting up HEC-RAS model from scratch. So that's the one way to set up. So we have one model that is basically 1D model with steady run condition for a specific location, right? For 100 year of return period of water level and flow rate. So in the next tutorial, I will even show you how to calculate these values, and at the same time I'll show you the breeze location, because we know we have the breeze, right? We have to insert the breeze. We have this option here, breeze or culvert. If I click there, it is asking where, right? Which one or which cross section will be our breeze cross section. We have to even specify everything. I'll show that each of these tools, and then our breeze section will be there, right? In between section number 4 and 3, right? There we have the breeze. So we'll insert our breeze, and then we'll insert the piers and everything, and it will look like a breeze, real breeze as well, okay? And then we can even run the model. We can see there will be some velocity changes, and even though we are gonna calculate that scour at the end, hydraulic, we'll do some hydraulic calculation, and based on that we'll be able to calculate breeze scour. And what will be the scouring? There will be different types of scouring. From a breeze scour, it is called a pier scour from breeze pier, and there will be scour from abatement of the breeze, and there will be some local scour as well. So we'll combine them together and we'll add them up, and then we'll calculate the total scour, and based on that scour, if it's necessary, we'll have to provide some piling while constructing this breeze or not. So that's the idea. We have to be able to calculate everything. So I'm gonna finish off here, and you can try by yourself, and if there is any problem, let me know. It is pretty simple, and I'm giving you every data you need, and then you can try by yourself. And good luck for you with your new modeling tool and new learning. New learning is always challenging, but you have to be patient, and you have to continue, and you have to try by yourself. Then you will be able to run any model and will learn new thing. At the beginning, you may find it, okay, it's very difficult to find this option, that option, but within 1 month or within a few days, if you just use this repeatedly, then you can remember every options you have, right? And yeah, definitely I'll show you everything and what is the capability of this model. So using this HEC-RAS model, we can do steady flow, unsteady flow, even water quality modeling, sedimentation problem, and 2D flood modeling, scouring, everything we can do, and I'll show you that time to time. Okay, so that's that. Thank you very much for watching, and stay safe. See you in the next tutorial.